So this is the topic of our talk. Is it a coincidence? Yeah. Is it a coincidence or just mathematics? There is nothing related to dinosaurs in this, but it looks cool. That's why we put it here. Okay. That's about it. Yeah. So let's start. Okay. Okay. Can you guys guess which city this is? Anyone? Yeah, okay. Yeah. It is Bhubaneswar. Okay. Now can you guys guess what is like the population of Bhubaneswar? I mean a random guess. Any guess? Okay, nice. This is like, yeah, it's 1.2 million basically. Okay. Now let's see what's the aim of our talk. We want to show that there exists a group of people in Bhubaneswar with same amount of hairs. That's about it. But there is a very huge hurdle that comes between us and our aim, that is balding. Okay. It is very prevalent among men, especially grown men. Because of that, it hampers our data. So we'll do something about it, basically. We are taking that around 20% of the population suffer from baldness. Because of women, we get it 20%, but when it comes to men, it increases. So we are taking 20%. Okay. So this reduces our sample size, basically non-balding people, to 9.76 lakhs. Okay. Yeah. Okay. Now where's the mathematics? So we need some mathematical tools. The first one we need is pigeonhole principle. We couldn't find pigeon here, so we can work with a sparrow here. Okay. Now I'll explain what pigeonhole principle means. Most of you probably don't know as you are in first year. If you know, then great. Let's see. Okay. Suppose there are like 5 holes. Okay. Okay. Take it. Okay. Suppose there are 5 holes. Okay. And we have 6 pigeons. Now, what we are claiming here is at least one hole has at least 2 pigeons. What I'm saying is at least one. Because every single pigeon has to go to a hole. Yeah, that's the compulsion we are putting. So they can go in any one they want, but what we are claiming is at least one hole has 2 pigeons. Say if that doesn't happen, so the maximum amount is 1 then, right? So 1 here, 1 here, 1 here, 1 here, and 1 here. We are still left with a pigeon, right? So we have to put it somewhere. So any one of them will contain 2 pigeons. So if we try to generalize this, we can say if there are n plus 1 pigeons, then at least one hole will have 2 pigeons. Make sense? Okay. If we generalize this even further, we can say if there are mn plus 1 pigeons, then at least one hole has m plus 1 pigeons. Does that make sense?
There are n holes, right?
Yeah, there are n holes. So, any doubts? Is it clear? Sure? Okay. Okay. Okay, sure. What I'm saying, if there are mn plus 1 pigeons and n holes, right? So, at least one hole will have at least m plus 1 pigeons. Suppose that doesn't happen. Then what will happen? That we are saying that at max we can have m pigeons. If you are saying that it doesn't happen. So each n of them will have m pigeons, m pigeons, m pigeons. So if we multiply m into n, that's mn. We are still left with a pigeon, right? So we have to put it somewhere. Yeah. So yeah. If we generalize this even further, we can write it somewhat like this. डस्टर कहाँ है? Now, if we okay, so let me explain what this thing means. It's a roof function, if I'm right. Yeah. So say n is 100, m is 12. We'll get something 8 point something, right? 8 point, let's say 7. If we apply, like, write the roof function on it, what we'll get is 9. Basically, the smallest integer greater than the one here, like the number here. Does that make sense? Okay. So what we are saying is, if we have n pigeons and m holes, so there must be one hole with at least these amount of pigeons. Why would that happen? Is we can say if n is greater than m, we can write it somewhat like this, right? mq plus r. N is greater than m, we are writing it as mq plus r. Okay? And where r is between 1 till m. Okay? And I'm claiming that there will be a hole with q plus 1 pigeons.
Strictly less than n.
No, I'm using it for a reason. I'm not taking 0 because of that. Yeah. So what we are saying here is, say it is somewhat like this, right? So we can write it like this, right? Which is like this, q plus r by m, right? Which means q plus 1. Does that make sense? Yeah. So that's basically what we are using. If n objects are placed into m boxes, then at least one box contains at least like this many objects. Okay, now we'll try to apply this to our question. What the question we had, like, first for that we need to identify our boxes and our objects. Okay.
How's that q plus r by n that becomes q plus 1?
Because if I divide it by that, we get q plus r by m. Yeah. And this r by m will have some value, right? So it will be, say q is 8 and r by m is something 0.02. What I said about this function was, it will take the smallest integer greater than this. That's why it's q plus 1.
How are we sure that r by m will be less than x?
From that condition.
Acha, okay, got it.
Yeah.
Got it. Got it.
Okay. So now we'll try to identify our boxes and our objects. Okay. So, do you guys know what is the average range of a non-balding person's hair? Like the amount of hair he has?
90,000.
I mean, yeah, it is in that range. It is around, we can say around 50,000 to 200,000. Okay? Yeah. Don't quote me on this. I saw it in a book. Okay? Yeah. So we are taking boxes like this. A box where the people who has this amount of hair, they go into that. Okay? Okay, so the total amount of boxes we get from this is 1, 2 till basically these. and we knew that our objects were humans, right? And we had the number right there. Okay, so this is the amount of objects and this is the amount of boxes. Any doubts? Okay, now we'll apply the formula that I told you. It will be somewhat like this. 9. Yeah, so it will come about something like 6 point something, right? And we know what this thing does. It will be 7. So what we are saying is, so there exists at least 7 people in Bhubaneswar with same amount of hair. Does that make sense? Yeah, but this is not enough for a sum stock, right? So we have to do something else. Let's try. Can you guess which institute this is? Take a wild guess, please. Yeah, right. Yeah, this is NISER. Okay. We have around 2,000 people in the NISER family. Okay, but we also have professors, right? So that reduces our population, non-balding population, to 1,500. Okay. So yeah, we have a new aim in our talk, and that is, does there exist at least 2 people in NISER with the same amount of hair? We'll try to find what is the probability, what is the chances that there exist 2 people. Okay, we need some more math stuff for this, and the thing that we are using is complement principle in probability. You might ask, what does that even mean, right? So what it means is, chances of something not happening is equal to 1 minus chances of something happening. Okay, right? So let me write it down. Here A is an event, right? What is our event? Our event is, there exist at least 2 people in NISER with same. So what will be the complement of that? A complement. It is, what it would be is, all people in the NISER community have unique hairs, unique amount of hairs. Okay. So what we need to do is, probability of at least 2 people with same hair is 1 minus probability of all distinct. So now what I need to do is find the probability of all them being distinct, and we'll basically get our answer, right? Okay. Now let's see how we will do that. Okay, so probability of A complement will be, let's remember what we are doing here, right? We have around 1,500 people, right? So the total options a person has is 150,000, right? Because of the amount of hair we took was 150,000. And the first person here can have any amount of hair he wants. That would be 150,000. Okay. Now the next person, he cannot have the same amount of hair as him, so that would be Does that make sense? This part, right? Okay. So what I'm saying is, the total, what what type of, like, the amount of hairs is fixed, right? We can either, like, the range is fixed. It is between 50,000 to 200,000, right? So we have 150,000 options, right? And what I'm saying is the first guy can have any amount of hair he wants, right? It won't collide with anyone else, right? But the second guy cannot have the same hair as him, same amount of hair as him, right? So that's that. It will go on till not 1500, this, yeah, yeah. Oh no, we have 1500 people, right, in NISER. Yeah, we are doing it for every single person. So this is the 1500th person. Okay, so it would look something like this. Right? Now, something like this can be written like does this part make sense? Yeah. Okay. What I'm saying is, in the numerator we have from 150,000 till this, right? So what I'm writing is, I'm writing a factorial instead of that and dividing it by this factorial. Okay. And in the denominator we already had this 1500 times, right? 150.
Raised to power 15.
Yeah, because we had 150,000. Yep. Yeah. So we'll calculate this and get something around this, which means the probability that at least one person has same hair with someone is this, which can be written as the probability, like in percentage, it is 99.945, which is, I think, pretty much guaranteed in my opinion. So yeah, that's about it. Thank you.